In this lecture, we will talk about tensile test. The remarks that I will make in this lecture applies to mild steel, but other engineering materials also show the same phenomena to a varying degree. Now, usually tensile test is carried out on a bar of uniform circular cross-sectional area, which is tested in universal testing machine, abbreviated as UTM. Now, for small strains, we use extensometer or strain gauges or strain gauge. In this test, load is applied gradually. Here is a typical stress strain curve for mild steel. From point O to point A, you can see that strain is directly proportional to stress. This relation is famously known as Hooke's law. Point A here in the curve represents limit of proportionality. Hooke's law applies within the region of limit of proportionality. After this also, material may be still in elastic state, which means that if the load is removed, the strain will return back to zero. That means till point B, if we keep on increasing the load, and after unloading, the strain will come back to zero again. So this point B is known as elastic limit. The point till which the body remains in the elastic state. After this, if the material is loaded, some plastic deformation will occur in the material. After this comes point C, which is known as yield limit. At this point, metal shows an appreciable strain even without further increase in load. You can see that in the curve at after point C, the material shows an appreciable strain without any further increase in the load. In actual test, let me erase this first. Now, in the actual test, further extension is not measured by strain gauges. It is measured by dividers and scales. Okay. Now with mild steel, there is an immediate drop as soon as the yielding occurs. So there are two yield points. One is upper yield point and there is lower yield point. Strain in the region from point C to D. You can see from point C to point D. The strain in the region from point C to D is about 100 times of the strain in the region from point O to C. From O to C. Strain in region from C to D is approximately about 100 times strain in the region O to C. But mostly it's permanent or plastic strain. Permanent or plastic strain. Now at point D, necking starts. at point D, necking starts. And load starts to fall until point E, where fracture happens. From D to E, load falls, and finally um, D to E load falls, and at E material finally fractures into two pieces. So now, to find maximum tensile stress, we would divide load at point D to the original cross-sectional area. Mind this is not the true stress at point D, because the material has necked at point D. This is how the cross-section at point D will look like. The bar starts to neck. This will be the new cross-sectional area. So the true stress should be load at D to the cross-sectional area at the necking. So this is not the true stress, but this is of the interest to the designer. This is the stress which a member can withstand over its original area. Although the load at D divided by the cross-sectional area at necking, this would not be also the maximum tensile stress. Maximum tensile stress will occur at point E, where the fracture happens, because this will have the minimum cross-sectional area, leading the stress to a maximum value. I hope this clears tensile test for you, and we will meet in the next class. Till then, bye.